Hello. So we're here with the next episode of the WitMotion driver. So for acquisition of the data, I made the fonts a little bit bigger for those who want to see more of the code and all of that. I watched it, I reviewed the video, and I saw that okay, maybe it would be beneficial to increase the font size a little bit just to make sure that they are more visible, especially if you are watching with the lower resolution and YouTube. So what we did in the previous episode, we actually implemented the serial interface, and it was very easy. Just the method for opening the channel, closing the channel, receiving data, sending data, and all of that. And today we are going to implement the decoding part of the code, and then later in the last episode we are going to implement how put these together and actually implement the IMU handler and use it in a program or something like that, or maybe just implement a test or something. So let's do that. So basically we are going to implement so first, of course, as usual, we add our header and source code. Yeah, and here let me close this, and here we are going to start implementing. As usual, for this one, I'm going to define the macro wrapper just to make sure that we don't have any error in case of repetitive including, or like including one header in multiple files that they are included in another one. Yeah. It's it's a little bit unusual for me. The phone is too big, but that's fine. Okay, perfect. So this episode can be a little bit longer than the previous one because we need to do a lot of decoding for every kind of packet, every kind of packet that we're gonna get from the sensor. So basically, what the sensor, the WitMotion sensor that we are working on, transmit data through data packet, and each data packet is flagged with one type of data, whether it's a GPS information, it's accelerometer, gyrometer, or whatever whatever it want to send us. There is a code inside the packet that shows okay what type of data it is, and for each of those we need to do different kind of decoding to understand, to get the data that we want. One important thing is that in the concept that we are implementing, I mentioned that it's like a subscriber thing. So when we get a message, we decode it and then we subscribe it to our listeners. So keep in mind that this is the concept that we are implementing. And for doing that, so we did the first step. Now we need to start implementing the class and also implementing the source code related to each method. First, based on the documentation of this sensor, the body size of the packets that this sensor sends us is 8, so 1 byte, and yeah, I think so. We're gonna check later, but I remember correctly because I'm looking at my notes. So if it's not the case, we are going to fix it later. And now I'm trying to actually implement an enum that shows different type of packet that we are going to get from this sensor. So time is one of them, and of course I need to add so this value that I assign to this item is actually the same code that my sensor begins the data packet with that. So I'm going to do that, and then maybe acceleration, which is 0, I think 51 in hex, and angular velocity, angle 3, magnetic field values, which is lost the opportunity to actually use that. That's fine. Port. What else? Barometer. Barometric altitude. For a second I forgot whether altitude had 2t after I or not, and then location, of course, 7, and GPS 58. And quaternion, yeah, and GPS accuracy, yeah, it's just to follow the camel case thingy that we are doing, which is 5A, and the name of this enum, let's say data packet code, something like that. Perfect. Now we also need a structure that contains the data packet, basically. So let's define that. Yeah, perfect. So in here we maybe receive packet is not a good idea. Maybe data packet is better. Yeah, I like it better. And then we are going. So the fields here are the code, which I mentioned. It's 1 byte. Yeah. And also the body. Yeah, the body. Yeah, I need to correct it. So it's 8 bytes, not 8 bit. Yeah, I don't know why in my notes I mentioned 8 bit, but 8 byte. And the last code is the CRC. Of course, this is straightforward, and that's it. So these are the things that we need, and as you can see, I made a mistake here. The next one that we would need is so basically now I need a structure to contain the messages, so decoded messages, but we're gonna use inheritance of structures for that. And yeah, now this one would be a nice thing to do. And for all of these messages, one of the things that they have in common is the code. So what is the code, and what is the type of message that they actually this decoded message contains? So let's say first, of course, we need to have a constructor packet, and the constructor for this is, of course, to initialize the code. Since we have it, it's okay if the name is okay, but the name are the same, but then you need to use this to mention, to show that, okay, whether it's a scope dependent variable or it's the class field that you are initializing. And for that, I try to not use the same code, the same thing for my argument and my class field. Yeah, great. So I did that, and now we are ready to go for the next part. Yeah. Perfect. Oh yeah, it's better you do that, because the problem here is that when you use type def structure to define a structure, then it creates an unnamed or with a random name structure and then redefine it to data packet here. But here we want to create a construct and all of that, so we need to have a named structure here. That's why it was giving me hard time. And here, because we didn't add anything here, which is reasonable, I usually add things before start implementing, but here I forgot. So for the data type, I'm gonna use the standard integer, and then also, because we are going to use some string and like character streams, it's better we also include this string. And also we are going to do some like lame mathematics, and we are going to use that too. Perfect. Yeah. Great. So this is the first step. The second step is to actually implement the constructor, and to do that I'm going to, well, one thing, it's better you use explicit here. I'm gonna add a comment here that why we are using explicit later, and then we are going to use to make a constructor, and we make it default. So we're forcing the child method to implement the destructor, and also we need to add the how to decode it. So we just add a parse method, and then data packet, of course. Yeah, here when we assign 0, that means there is no implementation for it, so it forces the child method to actually implement this, otherwise they get an error. And for the other part is that we just convert it to convert the packet to a readable string, just to make sure that we have some sort of a string presentation of the packet if we want to show it in the console or make a log or something like that. So this one is ready. Now sorry for my voice, and yeah, I think I came up with a cold or something like that. Now we need to implement another the first type of our messages, which is let me see my code. Okay, yes, time packet. Let me see. Yeah, the first one is the time packet, which is one of the packets that this sensor actually provides, which is the time. And yeah, great. So based on the, if you guys want to get more familiar, it's better you read the documentation of the sensor while you are trying to follow this code, or maybe later if you want to implement your own code for it. And since I don't want to initialize it, I just use yeah, day, hour, and minutes, seconds, and milliseconds. Perfect. And for the public one, yeah, I like to make my code clean, which is not a bad thing. It's really good to do that, since in bigger projects you will have problem if your code is messy, and messy code creates undebuggable kind of code for you, that you have to it forces you to re-implement it just to make sure that you can actually survive debugging and running the code. So we created the constructor. Now we want to actually use the parent constructor to initialize the data. So we need to convert the enum that we made here to the thing that we actually to the code that is recognizable. So what we are going to do, we use static cast. It was uint, I think. Yeah. And then we used dp code time packet, which is not the correct. Perfect. Of course, I'm going to use the antibody. It's just an announcement. You are not required to do that. It's just something to make your code more readable. And for of course, we have to implement the data packet. Yeah, you have to implement the data packet, and of course we are implementing it. So let's do that. And for the next part, I'm going to use this one. So here I don't need to go to just make my source code like longer by implementing everything there. So I'm going to implement it here because there is nothing that I want to hide or like from the header file. So I'm going to do that. It's just a simple string presentation of the packet that we are actually using. So we are decoding, and so I made a string stream. So it gives us something like the stdc out, so we can use that kind of initialization and adding value to it. So something like this, and then I'm going to do the static task of int16 to for the year. Yeah, very sorry. Perfect. And then we do something like that. Month, day. We do that until we have the hour, minute, second, and at the end millisecond. Great. So when you prepared your string stream, now you just need to return the string presentation of that data packet. But if you want to add other things, you just add it here and don't worry about it. Great. Give me error because I didn't add semicolon. Today I'm a little bit sloppy. Sorry about that. It's because I got cold, so I'm a little bit distracted. The next one would be acceleration packet. So structure acceleration packet, which will inherit from the receive packet. And let's define the fields. For this one, we have few fields for it. So the first one is the acceleration for axis X. So I'm just doing that. Of course, the naming is unconventional, but since we are, I think it's better to be defined like this. In my eyes, it's more beautiful actually. And there is a temperature field based on the documentation. Yeah. For this one, again, I would need to do this. Perfect. And here, like this. And for, yeah. Everything seems okay. What is the error here? I don't know, but we will figure out later. Of course I know. That's happens when you're implementing in different languages, so sometimes I mix up the syntaxes. Yeah. And later, since it's override, we add the override flag here. And the last part would be the string one. Yeah. Yes, I didn't write override for this one, so I'm going to use that. It's better, it's more readable. Perfect. And for the accelerometer, let's just I'm going to use this one and also this one. We can make some more like encapsulated methods just to make sure the amount of code that we are implementing is less than what we want, less than should be. And I just copy this from my notes because we don't need to write everything here. It's just we are coding together and we do a lot of copy pasting while we are programming. So that would define. And then the next part would be the structure angular velocity packet, which gets from receive packet, inherit from receive packet, and the field would be, of course, let's say the same thing. So here, for example, if I want to implement it with less code, maybe I implement another structure here that let's say vector packet, and then I define XYZ field, and then I inherit from receive packet. So from then I can actually inherit the acceleration packet and all of that using the new base class that I mentioned here. But now we just stick with this design, this type of coding. So we are abbreviating the So I'm copying this here. I just change that, and for this one, this one would be the same, and for this one we just need to maybe angular velocity, something like that. AGA, and so as I mentioned, I'm a little bit tired, so as you saw, I just edited the wrong thing. That's why implementing actually the copy pasting during your code is very important. You be in a good state of mind, because sometimes we do things that just we want to reduce our implementation time, but if we don't do it carefully, then you have to spend a lot of time again to fix the bugs and fix your code problem. So just be mindful of that. And for this one, we have, for angle packet, we have row, of course, yaw, and pitch. And also we would have another packet version based on the documentation of the sensor, so don't worry about it. And later I'm going to copy all of these here. Just use this one, and for this one I use angle. And let's say we print it with the same order. Perfect. So this one is ready too. I just need to make this angle instead of that abbreviation that we use for the other structure. Next one is magnetic packet. Perfect. Great. So this one also has the same field as this one. I'm just copying pasting that. Yeah, sometimes you need to, well, while you are working, another note, while you are working on different sensors, it's better you read the document first and maybe summarize it for yourself, because during the implementation you have to refer to that. Like me, I made a lot of notes from the documentation, so it would be easier. So for example here, if I didn't have these notes, I had to go back to the documentation, like review again the documentation and then make sure that I correctly defined everything. So what I'm doing here, I'm just looking at what I had and then go from there in my notes and go from there. And for this string, I just add maybe mag. No, mag would be okay, and we just need to update these values. Yeah, perfect. The next structure that we need to implement is, oh yeah, barometric altitude. Which gets from receive packet, and we are going to define it. So this packet has only two fields. One is the air pressure, which I forgot. Another one is the altitude, that is calculated based on that air pressure. If you want more information, you just need to go read a little bit more about barometers. Yeah. It's better I do this here. Let me see if I have it yet. You don't need to make public, because without it, for classes is opposite, but for here it would consider it public. Yeah. Perfect. And for that one, I just copy from my note because it would be faster. Yeah. So the next one is location. Perfect. So this sensor, the GPS part, gives us location in longitude and latitude format. So but without any decimal. So be mindful about this. Yeah, perfect. Yeah, and for this, again, I copied from my note. We don't need to implement everything here. This is more straightforward, so I decided to use my notes instead of using the other things. And the next part is the GPS information. Beside the location, GPS provide other information like airspeed, like estimated altitude and number of discovered satellite, all of that. And we are going to use that. And of course heading, that's very important. So let's define them. Is altitude, but this is the altitude that GPS provides. So we will have two type of altitude, and they may be different. Perfect. And again, we copy, paste these. And again, I will copy the information here. Great. Yeah. The last part, no, it's not the last, so I don't mention it as the last part. The next part for our GPS data is GPS accuracy, which is another type of packets that we are actually using. We're gonna receive. So for the accuracy part, we will get the number of satellites. Yeah. What else? The position accuracy. The accuracy of the horizontal one. Or better to say precision. Yeah. Perfect. Yeah. Great. So this one is done too. Now, next packet. So for this one, we will have as the definition of this field is obviously show us is 4 different values that presents location for us. So and I'm going to copy paste everything. Yeah. Perfect. So these are the how can I say data packet that we wanted to decode, and but now we need some sort of function that make the message based on the data that we are receiving or data packet that we are receiving. So let's call it. So I'm defining a function without any class, and it's not an object-oriented thing to do if you want to make sure every part of your code is aligned with object-oriented implementation, you're gonna avoid these kind of things. But for me, I like it when I am flexible enough to use different type of programming paradigm when I'm implementing the code. And yeah, that's it. So we have all the class definition and class method signatures, and now we are going to implement the source code. And in the source code, for every message, we are going to implement how to decode that message. Okay, so in this part, we are going to implement the going to implement the decoding process for each of these like messages, and we go from there. So the first we want to implement is the time packet. So we want to implement the decoding part of the time packet, but before that, let's include the header file from the message. Okay. Yeah. And also for showing messages on the console, I'm going to include the IO stream. And for our decoding, and also for like converting the formats in a more desirable like type or format, I'm going to do some basic mathematics, and part of that I need to know the gravity force, and let's say it's just 9.8. Okay, so the first one, let me use this here. Great. Okay, so the first one is the parse method for the time. Let's go up. Yeah, here, time. So we, as all of us already use this time packet, parse, and then what was the, okay, data packet pd gray. Okay, so for this one, every byte inside the data packet shows one of the like year, month, or day value. So this one is very straightforward. So we say this year, we say pd dot body. So this one, so the first index is the year. The second one is the month, and the third one is day, perfect, and then we have hour, minute, and finally second. Well, not finally, but at least for this part. And now for the millisecond can be a huge number, so it cannot be contained in a like 8-bit integer. So we have like it saved well, it transmitted in 2 bytes, and we just need to make it stick it together, and then we are good to go. So for this part, the lower part is the earliest index, so it will be 6, and the bigger part would be, yeah, perfect, and it would be a simple shift and or, so it will be uint, of course, and 16, so 2 byte data, 2 byte integer, and then we have the MSH or the higher byte, and I just move this 8, I shifted 8-bit, and then I do MSL. I make an OR with MSL, so it's very simple. So you shift it, you shift it to the left. So let's say if it's 0 0 0 1, if you shift it once, it will be 0 0 1 0. If you shift it twice, it will be 0 1 0 0. If you shift it like till end, it will be 1 0 0 0. So something like that. When you do that, when you shift it 8-bit to the left, the first 8-bit will be 0, so there would be a room to add the other part. So it's not a like sum or multiple normal operation. You just need to make your double 2-byte integer. So yeah, that's it. So for the next one, we go for the acceleration data. Yeah, this one, perfect. Parse data packet, PD, yeah. And then for this one, the data follows really like a simple thing. So let's say for x-axis, for like axis x, what you have is similar to what you did for the millisecond part, and with some extra operation. So first you need to create your 16-bit integer. So let's say it's x, the higher byte, you shift it 8-bit, and then you do an OR to create the whole data. And then based on the documentation, you just need to actually divide this to this number 32 768, yeah, and then multiply this value to 16, yeah. Yeah, so what we do, we create the 16-digit integer, divide it by 32.768, and then we multiply the result of this to 16g, and the g is the gravity that we actually mentioned here. So this is the formula for decoding this part. So for example, for AC, let's say I'm gonna define one variable and then reuse it over this method. So the body, the first one, the second byte is the bigger one. I just shift it, and then so this is the different with the this is the different with the millisecond one. So I just sum it. I just make a sum of this one and the lower part, the lower one. Yeah, perfect. And then you just need to assign, very easy, AC divided by what was the, yeah, exactly, and then you just multiply this by 16 and then gravity. That's it. Easy. And then you just apply this to the next one. So it will be 3. This one will be 2. The same thing. Yeah. And then you have again 5, 4, and yeah. So when you did that, the last part is the temperature, which would be a simple, it's a simpler one. So I use the same temporary variable that I used for the previous calculations, and again the same thing. I shift it to the left 8 bits, and then I might multiply it. Yeah. And lastly, I'm going to assign the result to what I was expecting. So instead of why we are so the data that it sends us is actually in decimal, but it's like a fixed decimal. So instead of like sending a float data, what it does, it just send an integer, and it, like, you need to assume that the 2 last digit is the decimal points. So that's why you divide it by 100. Okay, the next one is angular velocity packet. So you do okay. So for this one, we have a similar formula like this one. Yeah, but with some differences. So you do, let's put it like this. So you do the same thing here, related to the lower byte and the higher byte, and then you have again a division of this one, and instead of multiplying by 16G, you just multiply it by 2000. That's it. Okay, so let's do that. I think I'm gonna copy paste this and then go from there. It makes it easier. So it will be instead of this, you just do 2000, and that would be it. Same thing here, the same thing here. Yeah, AVY, AVZ. So what I saw here is that there is something that I did wrong. So I just got. That's why copy and pasting sometimes make your life miserable, because if you don't copy paste properly and you do it like in a hurry or something, it can cause a lot of problem down the road. So let's do Okay, for angle packet, it's very simple. We just need to create the same formula. So we say angle. It will be something like let me see. Yeah, the same. So you just it's a 1 byte thing, and sorry, 2 byte thing, and then you just do the same thing like here, and then divide it by what I mentioned here. Yeah, and then multiply it by 100. That's it. So let's do that. So I'm going to int AC equal to PD body 1. So I'm going to shift it 8-bit, and then AC plus equal PD dash body 0. Yeah. And for example, for roll, you just need to divide this by this value, and then multiply it by 100. Yeah, easy peasy. Again, we do the same thing for the pitch. Why there is a space here? Yeah, and the same thing here for yaw. Exactly the same, but we put yaw instead of pitch or roll. And the last one is the version. I didn't make any comment for the other one, but let's make a comment for this one. So the same thing, but not the same thing. I mean the creating of that 16 digit. Yeah. And then you just plus it, sum it to the body 60. Okay, and this is the version that you actually want. Okay, so the next one is the magnetic data. So let's do magnetic packet parse data packet PD as we define in our class definition. Okay, so magnetic packet data is really straightforward. So you just, for example, for the X1, it will be PD body 1 shifted 8 bits, and then you just need to multiply it by why I didn't do that here. So you do that and then multiply it by the lower byte. Okay. Z and 5 and this one 4. Yep, and we have everything here. The next one is barometric at altitude one, so it will be barometric altitude parse data packet PD. Yeah, Okay, so for this one, it's a little bit more difficult. So here you see that it's 32 byte. So instead of just 16 bytes, so we just do one shift. We need to shift like from the biggest one to the lowest one till we have the value. So first we initialize. Like set it to 0, and then I'm going to go from the lowest one. We'll go from the lowest one to the highest one, and what I'm do every time I'm adding 1 byte, I shift 8 bit. So this way I know that all of my data is shifting all together. So what I'm going to do is that it just okay, is equal to 0. These are not this line of code doesn't need any explanation. Yeah, so I would say pressure plus equal, okay, so plus equal pressure, okay, 8 bit plus, that's it. So the first one, it just shift 8 bit to the left, so it's like nothing, and then I add that again. When the next one wants to be added, the next byte, it shift the one shift, for example, for body index 3, it will be added, then body index 3 will be shifted, and body index 2 will be added, and then body index 3 and 2 will be shifted, and body index 1 will be added, and so on, something like that. So I'm gonna do the same for altitude. Yeah. I make it 0. Now the start index would be 7, and then it will be equal to 4, and I plus minus minus, sorry, why I put plus plus here, okay, another put in my code, perfect, and then I will do the same thing here. That's it. Just make sure there's no bug or anything while you are implementing your code. And it's quite easy, but if you didn't understand, it's just to follow, just write like something, some data, like write an array of data, and then try to run this algorithm. It's a very straightforward method for this kind of thing. And then we go for location packet. It's like I'm following that. So for the location, we need to do the same thing, because if we go to the location, it's 32 bit. First we start with longitude. Yeah. So why write it when we can copy paste longitude? Yeah. And then latitude. The same thing for latitude. Okay. That's it. Now, for the GPS packet, for GPS packet, we have few things that we need to do. So we have altitude, heading, and ground speed. So let's do that. For the altitude, it will be, for altitude, it's the same thing we did here, but we divide it by 10. So it's like one digit, like decimal. Let's say altitude, and then we do body 1, we shift it, and then we add the other byte easily. Yeah. Very easy. Now for the heading, we do the same, but there is a 2-digit for decimal. So let's say heading 3, 2, heading, and so it's a 2 decimal thing. And for the other one, which is ground speed, again we have a bigger one. So yeah, we have a bigger one. So we need to actually again write the loop that we did before. Seven and I equal, yeah, perfect. Again, I put this boo-boo here. Shift it 8-bit, and then we, it's not a dot, it's this one, semicolon, and then at the end we just add, we just assign the value that we got to ground speed class speed. Perfect. So GPS packet we did. Now GPS accuracy. So let's do GPS accuracy. Great. For GPS accuracy, we have a number of satellite position accuracy, horizontal precision, and vertical precision. For the number of satellite, it will be a 16-digit. So I'm just simply do the thing that we discussed before. Yeah. So that's the number of satellite. Okay, for the position accuracy, we need to do similar things. So not actually want to bother you guys with repetitive explanation. So I'm just typing and let you guys follow what I'm going to do. The only thing that we need to consider, it has a 2 decimal, so I just need to do something like that. Yeah. So the next one would be edge precision, and for this one we just yeah, let's use this one. It's better you create it, but we have some variable unused here, so why not use it? And it's not like a very long code, so why bother? Yeah, you know, they say, people say lazy people can be really good programmers because they always looking for a way to do less time, do less, well, spend less energy to do a lot of things. So that's why I hope I'm anyway. Okay. Perfect. Yeah, okay, it's finished. Oh no. The last one is still remaining. So let's do that. So for the last one, I am so this one is also similar to the other one. The only thing that you need to make sure that there is a division with different value, the value that we actually used before. So let's first make these in a correct. Okay, so till here everything is similar, but this last part, yeah, this last part, instead of this one, you need to use this value. Very easy. And you can see all of these in the documentation, so it's not some magic I'm doing here. These, I'm just following the tips from the documentation, because it's not like complex calculation or anything. This is how they pack the data, so you just need to understand how and of course the code that we are writing, we need to test, debug it, because there may be bugs in it. So but you can see the updated one in my repo, so feel free for go through that repo and try to make it your own code. And I always not well, I'm as happy to actually accept the request for contributing to the code. If you guys want to actually add more features, or if you see any bug, just raise a pull request, fix the code, raise a pull request, and then after I review it, I'm gonna merge it to the code just to make sure everything is if everyone do their part. Usually the open source code would be very strong, as a lot of them are, and lots of people can use it. I really believe in open source projects and sharing projects, whatever it is, whether it's like a software, whether it's like machine learning, processing pipeline, whatever it is. I'm really supporting professionals, researchers, students who have time, or when they do something based on the confidentiality of their code or whatever it is and their NDA, they share some part of their code if it's not against any of their NDA, just to make others able to learn and also use it for their own project. The last one is the function that we actually defined here. Yeah. And then we have a receive packet. Okay, so it's not something very it's just for you guys to use it to make your life easier. It doesn't do anything specific. It just, well, we can add a lot of features to this one, but for now it just get a code and then create a message for it. So but then you can initialize whatever you want to do. Yeah. Simple as that. Why bother do a lot of coding? So this one actually help. You just pass what you receive from your serial port, pass it to this function, and then easily just get a message, and then add your data and run the parse without any need to know how can I say anything without the need to know, okay, what was the message or what object did I instantiate. So I just copy this part of the code because it's just repeated lines of code. I don't need to implement it, and then at the end, for the default case, I'm just making sure that if it was something it wasn't something like correct, I just let it know. Yeah, perfect. So we implemented everything. Yeah, awesome. So thank you very much. The next episode will be the IMU handler, which basically we integrate these two together just to make sure, just to get the data from serial port and then decode it using these like messages and decoding methods that we implemented here, and then pass it to our subscriber.